For literally thousands of years, humanity has looked up at the night sky and seen this profound mystery, a kind of celestial dance that just didn't seem to make any sense. So today, let's unravel how we solved one of astronomy's greatest puzzles ever. So here's the deal, the very heart of the problem. While all the stars move in this nice, predictable arc across the sky, some of these really bright objects, the planets, would do something weird. They'd slow down, stop, and actually move backward for a while before going forward again. I mean, what was up with that? So this is what they were seeing, this totally bizarre, looping path. Against that fixed background of distant stars, a planet like Mars would look like it was doing these little loop-the-loops. It seemed to defy all logic of a simple, orderly universe, and it was a puzzle that just demanded an explanation.
Now, to solve this, our ancestors had to first build a model of the entire universe, and that gets us right to the heart of the problem, the puzzle of the planets.
I mean, think about it. It's just common sense, right? You stand outside, you watch the sun rise in the east and set in the west. The moon and the stars wheel overhead every night. The most direct, obvious observation you can make is that we are the stationary center of, well, everything.
And this really powerful common sense idea led to the first big theory of the cosmos, a universe that was centered squarely on us.
And that's the geocentric model, most famously laid out by the astronomer Ptolemy. It put Earth right at the center, with the moon, the sun, the planets, and all the stars orbiting around us in these perfect circles. And look, it was a pretty elegant idea, and it dominated scientific thought for over 1,500 years. That's a long time.
Okay, but there was one massive problem. If everything is just moving in simple circles around us, how in the world do you explain that weird backward motion? Why would a planet just decide to turn around?
Well, the solution they came up with was, well, it was ingenious, but man, was it complicated. They called them epicycles. The big idea was that a planet wasn't just on one main orbit, it was also moving on a smaller, secondary circle at the same time. Okay, so picture this. It's kind of like a little wheel spinning on the edge of a much bigger rotating wheel. The path that a point on that little wheel traces out creates the exact looping motion they saw in the sky. So, from our point of view on Earth, this perfectly explained the backward dance. Problem solved. Or was it? Yeah, the trouble was, the more carefully astronomers observed the planets, the more their predictions were just a little bit off. And to fix it, they had to add more epicycles, and then circles on top of those circles, until the model became this mind-bendingly complex Rube Goldberg machine of an idea. And that's the real kicker here. The system kind of worked, but it was just so messy, so clunky. It's a perfect example of how we can build these incredibly complex systems just to hold on to an idea we think is right. It just wasn't simple. And usually, science likes the simplest explanation that actually fits the facts. And all that messiness, that dissatisfaction, it paved the way for a completely revolutionary thought, an idea that would change our place in the universe forever. And in walks Nicholas Copernicus with this stunningly simple alternative. He asked, what if we're not the center of it all? What if the Earth and everything else revolves around the sun? And here it is, the big aha moment. On the left, you see that complicated machine of epicycles you need to keep Earth in the middle. On the right, the new perspective. With one simple change, putting the sun at the center, the need for all those complicated fixes just, poof, it disappears. Because, get this, in this new sun-centered model, that whole backward dance, it's not even real. It's just an optical illusion. Think of it like this. You're in a car on the highway, right? And you pass a slower car. For just a second, it looks like that other car is moving backward compared to you. It's the exact same thing with the planets. Earth is on a faster inside track, and every so often it overtakes a slower planet like Mars or Jupiter, making them look like they're going backward against the stars.
So just like that, the mystery was solved. That strange backward dance was nothing more than an illusion. And at the heart of this brand new, elegant solution was our sun, which naturally leads us to wonder, what is this star at the center?
Okay, so let's just take a second to wrap our heads around the sheer scale of this star. First off, The sun makes up 99.9% of all the mass in our entire solar system. Everything else, Earth, Jupiter, all the planets, moons, asteroids, we're just the leftover crumbs. And yeah, it is absolutely enormous. Its radius is about 700,000 kilometers. To put that in perspective, you could cram over 1,000,000 Earths inside of it. 1,000,000. And then there's the core. At its heart, the temperature is an almost incomprehensible 15 million Kelvin. That's about 27 million degrees Fahrenheit. I mean, you can't even really imagine that kind of heat. That's the furnace where all the sun's energy is born.
So, the big question is, how does all that incredible energy get from that fiery center all the way out here to us? Well, to figure that out, let's explore the anatomy of our sun. All right, our journey starts right in the middle, in the core. This is the engine room for the whole solar system. The pressure here is just insane, over 250 billion times what we feel on Earth. It's so intense, it literally crushes hydrogen atoms together to make helium. And that process, nuclear fusion, unleashes a colossal amount of energy. So, that energy is created, and then it starts this incredibly long journey through the next layer, the radiative zone. It is so unbelievably dense in here that a single photon of light can't just fly straight through. It's like a pinball machine. A photon gets absorbed, shot out, over and over again. A trip that should be instant takes over 100,000 years. It's crazy. So after that super slow crawl, the energy finally makes it to the convective zone. And here, things speed up a lot. It's basically a giant cosmic boiling pot. Huge blobs of hot plasma rise up to the surface, they dump their heat out into space, and then the cooler, denser plasma sinks back down to get reheated. This is the final leg of the journey to the surface. And that brings us to the surface we actually see, the photosphere. This is where we see things like sunspots, which only look dark because they're a little cooler than their scorching hot surroundings. And just to give you one last sense of scale, that little black dot there shows you the size of our entire planet compared to just one of those sunspots. It's a great reminder that a simple shift in perspective didn't just solve an ancient mystery. It showed us that our world is just a tiny part of a system run by a star, more magnificent than we ever imagined. And it really makes you wonder, right? What ideas, what core assumptions do we have today that might just be another illusion, just waiting for a new perspective to completely change everything?